Hi class. Today we are going to look at a different way to solve simultaneous equations and find the point of intersection. So if you remember, that's where the two lines cross, that was the point of intersection. So today's method is called substitution. I like to think of substituting players in a sports match like this picture that I've put up on the slide. We use the substitution method when at least one equation is in the form y equals. For example, y equals 3x plus 2 or y equals x minus 5. So when there's just the y by itself equals like this. So then we sub that equation, the y equals 1, into the other equation. These are the steps to do substitution. So the first thing you need to do is label the equations. So equation 1 and equation 2. Then you need to sub one into the other. So we're always going to be substituting the y equals equation into the other one. And you need to write this down. So you might say, I'm going to sub equation 1 into equation 2. Or it might be the other way around. You're subbing 2 into 1. Then you need to solve. So you're going to be solving for x. So to find x, you'll just do the inverse operations to figure out what x equals. Once you have what x equals, you're going to put this value back into one of those first two equations, and this will give you what y equals. Once you have what y equals, you now have the point of intersection. So the point of intersection will be your answers. So it will be the x coordinate and the y coordinate. Let me show you an example. We're going to find the point of intersection of these two simultaneous equations. So my first step is to label the equations, equation 1 and equation 2. Now I'm going to substitute one equation into the other. So I always substitute in the equation that is y equals because I know what y equals. So I'm going to substitute equation 1 into equation 2. All right, so I'm going to write out equation 2, but instead of writing y, I'm going to sub in equation 1. So y equals 6. So instead of writing y, I'll write 6 equals 12. So I have 2x plus 6 equals 12. My next step is I'm going to solve this equation for x. So solve for x. And how I do that is I'm going to use my inverse operations. So I'm going to subtract this 6 onto this side. So I've got 2x equals 12 minus 6, so 2x equals 6. And then I'm going to divide by 2. So I know that x equals 3. So this is one part of the point of intersection. Now to find out what the y coordinate is, I need to then substitute this back into, so what I'm going to do now is I'm going to sub in x equals 3 into equation 2. So if I put this in, then I'll be able to figure out what y is. So equation 2 will be 2. Instead of writing x, I'm going to write 3 because x equals 3. So 2, 3 plus y equals 12. Now what I'm going to do is I'll rewrite it out again. So we've got 2 times 3, which is 6, plus y equals 12. Now I'm going to solve for y. So I'm going to subtract this 6 over to this side, and I'll get y equals 12 minus 6, so y equals 6. So now I have my y point as well. So therefore, the point of intersection is at the coordinates 3, 6. Example number 2. So we're finding the point of intersection of these two simultaneous equations. So I label my equations, equation 1 and equation 2. So now I need to substitute one equation into the other. So we're always substituting in the equation that is the y equals 1. So in this case, I'm going to substitute equation 2 into equation 1. So I'm going to write out equation 1, which is x plus, and instead of writing y, I'm going to substitute in equation 2, so which is y equals 3x plus 4 equals 8. So I'm just going to rewrite that out. I've got x plus 3x plus 4 equals 8. Where'd that little squiggle come from? So I've got x plus 3x, I've got 4x plus 4 equals 8. So now I'm going to solve for x. So I'm going to subtract this 4 over to this side, subtract 4. So I've got 4x equals 4. And then I need to divide by 4. So x equals 1. 4 divided by 4 is 1. So I know that x equals 1 is my first point of my intersection. So I need to then find out what the y value is. So I'm going to substitute x equals 1 back into one of the equations to solve it, whichever one we think is going to be easiest. So I might substitute it back into the second one, substitute it into equation 2. So now I have y equals 3, and instead of writing x, we know that x is 1 plus 4. So I've got y equals 3 times 1, which is 3, plus 4, so y equals 7. So this is my second point of intersection. So therefore, point of intersection is at the coordinates 1, 7. I'll show you now how to use the CAS calculator to solve simultaneous equations. There are more detailed instructions in my board notes on my Panola. So use the CAS to check all of your answers. So right now we'll check the solutions from the previous example were correct. Bring up the home page on your CAS by pressing the Home button. Then select Add Calculator. Then on your keypad you need to click Menu, go down to Algebra, and then Solve. So it says Solve here. Then on your keypad, you need to press the button that's got these squares on it. So click that, and then select this option that's got the 2 squares. So if we select that, it comes up with this. So in these 2 boxes, I can type in my 2 simultaneous equations. So x plus y equals 8. Then to get down to this next box, you can click the arrow down. And then we've got y equals 3x plus 4. Then we're wanting to tell the calculator to figure out what x and y is, so to solve for x and y. So we need to go across, click the arrow key across to the right. Then you need to type in comma, x, comma, y. So this is us just telling the calculator, solve for x and y. Then click enter, and then it tells me x equals 1 and y equals 7. This last example has one extra thing you need to do. So the first thing, I'm going to label the equations, equation 1 and equation 2. And the equation that is the y equals 1, that's the one that's getting subbed into the other equation. So I'm going to sub equation 2 into equation 1. So I'm going to write out equation 1, 2x minus 3, and now I sub in my other equation, which was x plus 3 equals negative 8. So then this is the one extra thing you need to do. Here, because it's not just 3 times one thing, I've got to multiply this by both of these parts of the bracket. So I'm going to have 2x and then negative 3 times x and negative 3 times positive 3. So negative 9 equals negative 8. So now I simplify it. 2x minus 3x, so I've got minus 1x minus 9 equals negative 8. And now I solve for x. So I better write that here, solve for x. So I'm going to plus 9 over to this side. So I've got negative 1x equals 1. And then I'm going to divide by negative 1. So x equals negative 1. So I've got my x point. So now I need to sub x equals negative 1, negative 1 into, so I'm going to just put it into one of my equations. I'm going to put it into equation number 2. So equation number 2 will be y equals negative x, negative 1, negative 1, where'd that go? Negative 1 plus 3. So y equals negative 1 plus 3, y equals 2. So this is now my other point. So my point of intersection, or my other coordinate I should say. So my point of intersection is negative 1, 2. So the only extra thing I asked you to do there was to expand the brackets, which is similar to some of the textbook questions. All right, a bit to take in that lesson. If you follow the steps, then you should be okay. Could you please complete the textbook questions? I'm aware that it's a lot today, so perhaps just do the first 2 or 3 by hand, then the last few on the CAS.